in the syllabus said that there are going to be some kind of group project assignments. All right. So the detail is this. So basically, it's in your class it will be divided to 4 big groups. All right. All right. So basically, right now I think that we have more international students, so maybe the number of the people in the group might be more. But basically, just you guys break into 4 groups. All right, and then the file is already in the OneDrive. All right, so basically the thing is that at the end, each group will be assigned to one of the technique. Yeah. All right, all right. Right now I have to randomly assign the top. So what I ask is that you guys give me the list of people, send me an email. When I have all 4 groups, I will assign the topic. All right, the key because if you send me earlier, we have more time to work on it. All right, if you send me late, meaning that you will know the topic later on, meaning that you have less time to work on the groups. All right, so at the end, the key is that after you have been assigned one of the topic, right? Let's see. Let's say you have been assigned for time series analysis. All right, what you need to do is that 2 things. First is to give me a project report. All right, report is basically just the first part is that tell me what is this technique. Give me some kind of rough what is this technique, what is the main objective of this technique. All right, what are the appropriate data for this kind of technique. All right, and then some technical or theoretical background on technique. So basically just study on it. When I read it, I know what they are. All right, when it falls. All right, and then the second part is to give me some kind of small research. Just think of small as just for that technique. Don't have to be big. All right, and from that small research, it needs to tell what is the objective of that small research. All right, and why that research needs this technique. All right, and what is the data that you use for this technique. For this, you can collect by yourself. You can ask people and collect data, or maybe you can find it somewhere on the net. But it's supposed to be some kind of real data. All right, and then how are they being collected? Is this a good data? Why not? That kind of thing. All right, and at the end for that part is that give some kind of result from that small. Yes, right, and then some finding and some conclusion, just small project on that. All right, and then the 3 parts also should include possible topic for IS independent study. This technique is going to be useful for what kind of topic. All right, and then also include paper version of your presentation. And then and second part is going to be presentation based on your report. All right, after you see 70% from the report, 30% from the presentation. All right, after I listen to your presentation, I should have a good understanding about the technique. If I listen to you, don't know what they are, what is, it's bad. All right, if after I listen to you, good understanding on when to use or not to use the technique. All right, when I listen to your presentation, a good understanding on how to interpret the result from the technique correctly. All right, and the last one is some idea on when this technique can be useful for IS. All right, so that's a group project. All right, you see, you have a lot of people that can share the risk with you. All right, try your best. Right? I don't care how you organize it, but I'll just look at that because like this whole topic is more like a advanced version technique of the class. If I have to go over all of them, it will take a lot of time. But if some of you have learned some of this technique, when you have to do IS, you can share, you can help each other. I think that's a good idea. All right, okay? Yeah. If you have any more questions about this, you can just send me email. All right, okay? So right now, just make sure give me the list of the people that are going to be in your groups so that I know we have group A, B, C, D. So that I can assign the topic so that you can have more time to prepare. Okay, huh? Yeah. All right. So last time, right? Last time we were talking about the test for 2 samples, the new thing, right? You see, what I have here is that this is old stuff. At the end of the test, you see, I have this free sheet, all right? This free sheet is basically just cover all the material that could be in the quiz number 1, all right? So far, right? So far, basically the test is going to be based on either you're dealing with quantitative or categoricals. This is all thing. You see one sample t-test. This is how you set up hypothesis testing, and this is a condition. At the end for the test, you do try to get the p-values. All right. The key, if you don't get this one, make sure you understand the output in all example that you have from last time. If you see the output and you feel dizzy, that's a bad sign. Okay, all right. Categorical data, you have this z-test that you done on the pre-course. All right, we haven't talked about this one yet. We'll talk more about that. All right. At the end, you actually copy and scan your friends, right? Yeah. And last time we learned about 2 samples. Only for quantity. 2 samples, we have 2 versions that pair samples and independent sample, if you remember. Alright? When you deal with quantitative, right, at the end you have pair sample, first thing you have to be able to tell why they are paired. Right? That kind of question will show up anyway. Alright? And then you actually calculate difference for each pair, and then you're talking about the mean of difference. And your question will be about the mean of difference. Alright? And the condition is going to be like this. Alright? And independent sample, you have 2 samples. So each sample are summarized to talk about the mean from first one and second one. So basically, you're actually talking about difference of 2 means. Alright? So your question will be about difference of 2 means. Mu1 minus mu2. The key, you need to know why they are independent. Alright? And what is 1, what is 2? Because when you flip the order, the meaning could change. Alright, you remember that calculating is not a big problem. The big problem is to interpret the results. Alright, and the condition for t-test basically pretty much about the same. But you apply on both of them. You see the first one, 2 independent random samples. You have to be able to tell why they are independent, right? Why they are random, or if not random, why they are good samples. Given or assumed. Alright? And then for check if the sample are from normal, there are 2 ways to check that. Right? By checking histogram and QQ plot. Alright, same old thing, right? Or you check by the sample size are both at least 30. If you remember 2 sample t-tests, there are 2 versions with equal variance and unequal variance assumed. Just be aware of that from the output. Okay? Alright? And last time, right, let's wrap up the material before we go through the software, right? So last time we were talking about this, right? You have this hand now, right? Last time we were talking about this, if you remember. There are many outputs, you see. So last time we were talking about the score of student on the first year. You have student A, student B, student C, student D. The key is that they want to see if the mean score of 4 schools are there any difference. Right? If there are some difference, imply that somehow school affect how they do good or bad. Alright? If the difference, meaning that school don't have the same standard. We talk about that, seems like A is somewhat kind of better than the other because the locations are somewhat higher. Alright? C seems to be worse than the rest. Something like that, but it's not big obvious. We also talk about this. You see, right? We compare by point estimation. At the end, decision based on 3 levels. Point estimation. Compare the mean x bar from A, B, C, D. See if there are any difference. But keep in mind, point estimation lack confidence. All right. You can argue that you can see A is somewhat larger than C. Right? But you're not sure if it's large enough so that you can conclude that there are some difference. Alright? Or you can use a confidence interval with 95% confidence level. Remember that if they're overlapping, they are similar. If they're not overlapping, you can conclude that there are some difference. Alright? Maybe you take a look at, since there are 4 of them, at least one pair not overlapping would be good enough that there are some difference. Alright? So maybe if you see, if you pick 97, 67. 67 is in all of them. So then all overlapping. So based on the confidence interval, it's not enough to say that there are some difference. Alright? So right now you see this setting is somewhat similar to two sample t-tests, but now there are 4 of them. Alright? To have 4 of them, right? The key is basically right now, let me ask you, this sample, you have 4 samples from A, from B, from C, from D. Are these 4 samples independent samples? The background is said that you have a student. Student A, high school, they are from school A. Student B, they are from high school B. Student C from high school C. D from high school D. Are these 4 samples independent from each other? Yes, because they are from different schools. Just that, as a keyword. Alright, so you have 4 independent samples. Alright, so right now, right, let's see. You have sample 1, you have sample 2, up to sample 3. And these ones are independent. Alright? So now you have K samples. They all visually independent. Alright? And they all are quantitative data. Alright? At the end, sample 1 you summarize to X bar 1. Sample 2 you summarize to X bar 2 up to X bar 2. Alright? And now since each one is to estimate the mean 1, mean 2 up to mean K. Alright? This is called mu, it's for the mean, right? You're supposed to know that already. Alright? So the question is that, are these mean all the same? Alright? Now you see, you have many means. Your big question is that, are these mean all the same? Are they all equal? Alright? So meaning that your S0 will be something like this. They're all equal. Alright? HA would be mu I are not all equal. Keep in mind when I say not all equal, it's different or not equal. Not all equal means at least one pair is different. When they say, if you say all not equal, meaning that have to be all different, they're not the same. Instead, in research, this thing is important. Alright? Not all equal means at least one pair difference. Alright? So that's our goal for this test. Alright? Are they all the same or are they not? It's very hard to say less than or equal, so it's just this version all the same and some difference. Yeah? No less than sign, no greater than sign. It's just all the same and not some different. It's become easier than before because no one-sided test. It's just this test. All right. Now my big question, right? So if S0 is true, right? Are X bar here supposed to be close to each other, or are they supposed to be different from each other? If S0 is true, X bar supposed to be close, because if the means are all the same, X bar supposed to be somewhat similar, right? If S0 is true, right? So meaning that the variance among X bar supposed to be large or small? Small. Because if they're all the same, X bar supposed to be close, variance among X bar supposed to be small. If HA is true, the variance among X bar supposed to be large. Alright? So my point is that at the end, this is what we call analysis of variance. Alright? Alright? The name ANOVA is actually a short name for analysis of variance. It's basically talk about variance among X bar. If variance among x bar is small, right, you tend to choose S0. When the variance among x bar is large, you tend to choose HA. Alright? At the end, right, the variance among x bar, right, you translate to what we call F test statistic. Right? The word is not good word, right? But this one just treat them just like T and Z and chi-square, right? Now just summarize to F, alright? But this thing is actually depend on the variance among x bar. If variance among x bar is large, F will be large. If the F is small, variance among x bar will be small. At the end, this thing will translate to p-value. Alright, yes?
What is that word in the parentheses?
Among x bar, sorry. Among x bar.
Thank you.
Yeah? Alright. Let's see.
Which university? National How was life in Thailand?
So in your sheet, it's actually on page 19. Alright? The F that I told you is basically just this part over here. It looks complicated. Just to show you, if you look at this part is the big, is translated to F, right? SST is basically just this part over here. You see this one, remember I say F is actually something similar to variance among X bar. You see, if you have three groups, you have X bar 1, X bar 2, X bar 3. Alright? And this one is X double bar, X bar bar. Meaning that you combine all samples and then you have the overall mean. You see, this one, if you remember the variance is what? Variance is the difference away from, distance away from the overall mean square on average. Alright, so basically if you get confused, this thing is actually proportional to variance among X bar. Alright, at the end you reject S0 when F becomes large. That's the key. But at the end, all you need is p-values. Alright, p-value. How do we use p-value? Reject S0 when p-value is small. Alright, so that's the key there. Alright, now if I go back to this one again. Now it looks like this. F looks like this. Right? This is F from sample. And the p-value is. Alright? Right now, what I want you to remember is that when you have k independent sample, when you have a question about are all means the same or are they not? Alright? Think of one-way ANOVA F test. Alright? This is how we set up S1HA. And then at the end, in technical term, it's actually going to summarize to F and then reject when it's large. So your F distribution looks skewed to the right, and then the areas of p-value will be on the right hand side. But if you don't get that, don't worry. What you need is to find p-values. At the end, for example, you compare to 5%. If alpha is 5%, if your p-value is smaller than 5%, choose 0. If it's larger than 5%, you choose up here, they're all the same. Alright? And the test comes with the condition. Alright? In this one, the condition looks something like this. See? All the same. They're not all the same. condition, think of extension of two independent samples. So now we have k independent random samples. So you have 4 schools, school A, B, C. They're from different schools, so they are independent. Random or good or not, check from the setting. Given, then you say given. Not given, then you that. And the second one, just like t-test, the condition is going to be similar to t-test, but more strict. You see, all samples are from normal. They have to be all from normal with equal variance. Right now, for ANOVA, they have to all be normal. Histogram have to look the shape. QQ plot have to look approximately straight line. And variance have to be all same. Okay, alright? So now, just take a look at output. Now, take a look at output. This output. The name of the test that we just learned is ANOVA. Alright? So basically, we're going to use this output. Alright? The one that you really want is basically just this one. Okay? That's the p-values. Alright? If you draw a picture, this one looks something like this. F is 357. This one. Right? But don't worry, at the end, all you do is just compare this p-value to some alpha. Alright? Before you use p-value, ask yourself first, what is S0 and what is HA? Alright? You only have one version, all the same, some different. Right now we have school A, B, C, D. Alright? So based on this one, S0 is mu A equal to mu B equal to mu C equal to mu D. HA would be mu I are not all equal. You know what I mean, right? In this case would be A, B, C, D. Alright? Let me ask you. Let's say alpha is 5%. Let's say alpha is 5%. Large or small? Small. Can I conclude that there are some difference in standard of school from 4 schools? Yes, because the mean are some different. So some schools are having higher standard, some schools have lower standard. Alright? Okay, same old logic. If you don't get this logic, it will be a bad class for you. Because every test is same old logic here. S0, HA, get p-value, check condition, just that. Alright? If I set alpha to be 1%, large or small? Large. Large, right? Can we say that schools are not related on how they are doing good in college? Can they say that schools are not related to how you're doing good or bad in college? Yes, because the means are all the same. No matter what school you are, they are all the same. Okay? That's how we use it. Alright? That's how we use ANOVA. Just jump to here, find p-values, and then compare to alpha, and then you conclude. Alright? But keep in mind that ANOVA needs how many conditions? 2. The first one, we talk about that. We have independence because they are from different schools. Do we have random samples? Go back to the first page, right? This one is say, I think that is the word, say random. So now we have 4 independent random samples. Because this one is say they randomly draw samples. I'll come back to write down for the question. But right now we see that we have 4 schools. They are from different schools, independent, right? And the question also said that they pick the sample randomly. The second condition, right? Second condition saying that all samples are from normal. This one is saying assume samples are from normal. So we have that part here. The question said that they are from normal origin. Alright? But the second condition are not just say they are from normal. You need that they are from normal with equal variance. All right, equal variance. How do we check that? All right, there are three approaches to check the variance. One is to compare box plot. Comparables IQR and range imply the same variance. Are these four comparables? I know it's subjective, but this one is not so bad. You see, it's not a big difference. But if you want to emphasize, you might say, well, these two are a lot different. Okay, and I told you this is subjective. It doesn't matter. You just pick one and then you go with your answer. It's okay to be subjective. All right. Also, you can compare S, standard deviation from A, B, C, D. If these four numbers are comparable, you can say equal variance. I know that it's also subjective because you see some people might think that these two are somewhat a big difference. Okay, but there's some trend there, but to me it's not big enough. Okay, just believe me, if it's not different by 3 times, 5 times, I'm still fine. From my experience. Okay? But using that is subjective, it's fine. Alright? But if you have like 4.1, that's comparable, huh? Don't say large different, huh? 4.1, that's a comparable, huh? Okay? But this one you can say different, you can say about the same, doesn't matter. It's okay with that. Right? Similar to t-test, the third approach is this one. You see this part here. It's a homogeneity of variance. Homogeneity means the variance are same. Okay, so meaning that this output is for checking if the variance are the same. Alright? At the end, all you care is this part. Alright? Same old thing. When you see p-value, before you use, remind yourself what is S0, what is HK. It's for checking if the variance are equal. So equal put on S0. S0. And this one is just an equal variance. You see, it's similar to two sample details. There is a part that helps you to check if the variance are the same. Alright? S0, let me put the star so that you know that this is the totally different hypothesis from on this side. Alright? Alpha 5%, large or small? Large. Can we assume equal variance? Yes. See? If alpha 10%, small, not the same variance. You see, this one I would say is a gray. Because if you pick alpha is 5, is have one answer. If you pick alpha is 10%, you have different answer. Alright, why is that? Because when you see the number, there's some evidence, but still is somewhat not a big difference. That's why it's showing up here. When sample is gray, it's also showing p-values. If you be close to threshold, something like that. But right now, if you get confused at the end, this one is for checking if variance are the same. If to make it easy, just based on alpha 5%, because this is not a main test, this is sub-test. Alright? Alright, you see, compared to 5%, this is large, so they can assume equal variance. Second condition are fine, meaning that you can use output for ANOVA. Alright, you see, this output can only be used when two conditions are fine. You have 4 independent random samples, we check that. Alright, second condition, the question given that they are from normal with equal variance. So you can use this output. Okay? Alright, that I will ask what is a p-value, then you have to use this one. It's based on alpha 5%, this one is small, some different among A to D. Which one different, we don't know, we have to go check in detail. Okay? If we cannot assume equal variant. What do we do? If equal variant cannot be assumed, if this one is small, imply that you cannot use this output. All right, what do you do? Turn out that we have this one. See? This one is called Welch test. All right, this one is called Welch test. Welch test is almost the same as ANOVA, but it doesn't require second condition. Meaning that if ANOVA fails, you're going to use Welch. Yeah. How do we set Welch? S0 and HA, they're the same as ANOVA, but don't need to have equal variance or normal distribution. Alright? So the goal, try to use ANOVA first. If you cannot use ANOVA, you come to use Welch. Welch at 5%, your conclusion would be that some schools are different. Yeah? Get my point? Huh? Check condition if audition are all made for ANOVA, use ANOVA. If you cannot use ANOVA, use Welch. Alright? That's why in my summary is that you see, second one I put no needed for Welch test. Second one you can skip for Welch test. Okay, right? But how we set up S0 and HA the same. Condition become more flexible. Okay, nah? Any question? Yes.
If you have to assume the alpha by ourselves, you have to assume the same alpha to apply to all tests.
Don't have to. Don't have to.
So you mean that in subcase you have alpha different from the
That's all. But usually for checking the variance are the same. I would say stage 5 to make it simple. Okay, man? Okay, so that, right? Any question for this? See, just if you understand two sample detail, this is just more like an extension of that. Keep in mind there's no large n. It's just normal with equal variance or not. No large n. Only for details for large n. Alright? So now, if turn out that you pick S0, they are the same, you're done. Don't have to find which one are different. But if you pick HA, some are different. The question after that would be, which one are different? If you have 4 of them, meaning that you have to compare each pair. How many possible pairs would you have? A to B, A to C, A to D, B to C, B to D, C to D. 6 of them. Alright, it's more like n times n minus 1 divided by 2, this kind of thing. Alright, so meaning that at the end you will have something like this. This one is more like comparing each pair. What we call multiple comparisons. Alright, multiple comparison. Alright, so you see you have A to B, A to C, A to D, B to A, they're actually the same, just switch the order. Alright, at the end what you have is this one. And this one. There are 2 parts. Alright, either one is fine, right? This one, right? This one is what, right? You see, we have confidence interval. Before you use confidence interval, ask yourself this interval is for what? Right? Turn out that this one is actually for mu I minus mu j. Alright? Right now, I is A and B is J is B. The second one is A minus C. The third one is A minus D. Right? Yeah? Right? If that pair is different, implies that if that pair are not different, it's supposed to include 0. Interval includes 0, that pair are not different. Not different, different, right? Only positive. A is larger than C. Not different, not different, not different, not different, right? Not different, this one is different, right? And then this one is not different, not different. At the end, what you have is only A different from C, all right? You see that this one is somewhat similar to confidence interval for two sample t-tests, but they are more. Why is that? Let's talk more a little bit, right? Remember that when you have confidence intervals 95%, how big is the risk? 5%. All right? So let's say you have 6 intervals. You have 6 of them. You have 6 of them, right? In order to have the overall conclusion to be correct, you need to have all of them to be a good one. If one of them is wrong, it's just wrong. Alright? If the very, very basic logic is that if you have 95% confidence level, right? Meaning that you have 5% risk for each one. If you have 6 of them, you have 2 of them, the risk become more or less or the same. More. You have more chance to be wrong. Right? So the very bad, very wrong logic, but still kind of valid. If you have 6 of them, 1 is 5%. 6 of them, 5 times 6. Because more interval, you have more risk that could happen. All right. So the person that adjusts this interval at the end, what you want is that the risk from overall supposed to be just 5%. So Bonferroni, what they do, instead of choosing 5%, they use 5% divided by 6. Alright? So if each one is 5% divided by 6, overall we have just 5%. Alright? That's the logic of that. But later on there are many techniques in order to actually make adjustment on that. Alright? The name that come up more often is that Bonferroni. You have Sheffield, alright, and then you have 2 keys, right? Later on in software, you will see 10 of them, alright? I would say just pick 1 or 3 would be good enough. My favorite would be 2 keys, alright? But I will not go into detail because if I teach you in detail, I have to test you, and you don't like that. Right? But the key is that all this technique is to make adjustment so that overall still have 5% risk. Some are good, some are bad in different situations. Okay, now, right? In my exam, I will always use 2 keys. If you see this one, I use 2 keys because I love that one. Alright, but how we use it, same old thing. But keep in mind, if you see, I use 2 keys. If I change the Bonferroni, the number will be changed. The result at the end could be different. Yeah? Alright? How we use it? Look for the interval that doesn't include 0. And that one implies that pair there are some different. Right now is this one. A is larger than C. Right now is also this one, which is the same thing as this one. Just flip the order. Alright? Using interval is good. If you don't want to use interval, you can use p-value. 6 is p-value. How do you know? What is a p-value? Before you use p-value, you have to ask yourself what is S0 and what is HA. Alright, this one is mu I minus mu j equal to 0. And mu I minus mu j is not equal to 0. You see what it means? These two are the same. These two are some different. To make it easy, this is a sub-test. Compare all this to 5%. You see? This one is small. Some different among A and C. This one is small. Some different among A and C. Same result. When you have many pairs to compare, this one becomes easier to look at. If you find with how we use p-values. Yeah. I know that it's just the second week for some second part, but next time we meet, I may not be your friend. Okay? But this logic is repeated many times. You are a good student. You can learn that. Okay, yeah. All right, so that, right? You get my point there, right? That's how we use for this thing, right? Look for which one are different. Or I sometimes also give you this one. This table is a summary of this one. What is this, right? There are 4 schools. What they do after apply this, you will have a summary to subgroup. If they are in the same subgroup, they are about the same. Subgroup 1 consists of C, D, B. Right? Meaning that school C are not different from D and are not different from B. Okay, this number are the sample mean from C, sample mean from D, and sample mean from B. Okay, subset 2 is D, B, A. D and B and A about the same. So based on this one, you can see A is only in subset 2 and C is only in subset 1. So A and C are different. Okay, or you can write down something like this. So A is about B, is about C, and about D, right? But these two are not the same. Something like that. Which sometimes can be very hard to summary. Some people ask, Ajahn, if A is similar to B, A is similar to C, how come A are different from C? Alright, just think of like when your friend told you, you look like George Clooney, yeah? And you said that your friend do you look similar to your friend, and your friend look similar to George Clooney? Are you the same as George Clooney? No. Changing by a little bit, and now then you are no longer the same as the one that you compare. Okay, right? Okay, that's how we use this one. Alright? So the logic on this one, first check they are the same. If they are the same, you're done. Right? If there are some different, ignore what pair that different. Okay, right? That's the output. Okay, right? Now let's go over the result. So first one, right? First one say that based on the information output 1 can be concluded that the variance of the average grade in the first year at university in the first year at the school A to D are equal. Alright? So main goal in here is that can we say that the variance from all schools can be assumed the same? Alright? So this key thing is can we say equal variance? Right? That's the main goal of that from 4 schools. And the best the part saying that use output 1. Only use output 1. Output 1, right? So based on output 1 is this one. The question asks for variance. So basically what you do, compare S. Your key is to talk about S. So in this one, I say from output 1, S1 equal to 7.2, S2 is equal to 5.41, S3 or SA, SB, SC, right, equal to 9.6, SD is equal to 7.31. And this, all of these are comparable. We have checked on homogeneity tests and they are all the same. So I say comparable. So equal variance. Okay? You can also think differently by just you say that these two are different and you say they're not comparable and you cannot assume equal variance, either one. Subjective. Okay, is explain, is this consistent with side by side box plot in output 7? Output 7 is basically this one. Alright, what kind of key thing you have to say? Compare IQR and range. Okay, and you have to decide comparable or not. This one is kind of gray. Alright, you might say, well, they're not a big difference, so they are comparable. I think this one I would say they're comparable. So from output 7, right, IQR and range are comparables. Consistent result. Okay? But you think they're not comparable, you can just say that. It doesn't matter. Okay, I think this one kind of great. So right now, I assume based on output 1, any question on this one? Okay, based on output 1, check if there are different in grading standard between 4 schools. So this one is what it's saying that can we say that mu A, mu B, mu C equal to mu D or not? Right? Are they all the same or are there some difference? Alright? In output 1 you go back. There are 2 approaches that you can do. Point estimation or use confidence interval. Which one is better? This one. If you compare X bar, you will not get full credit. I mean it. If there are 2 options, the one that's better have to pick the better one in order to get full credit. Because if you use this, you don't need this class. Alright? Alright? So based on this one, right? And the key is that are they all overlapping? You see, we talk about this. Every one of them include 67. Alright? So I would say that based on output 1, right? Confidence interval for mu A, mu B, mu C, and mu D are all overlapping. Alright? Imply that mu A is about the same as mu B, the same as mu C, and mu D. Right? No difference in grading standard. Okay, nah? You can try to get the logic for writing the answer. You see, compare all means, right? But the confidence interval, they're all the same. They're all overlapping. Overlap, the keyword is overlapping. So they're all about the same, so no different in grading from both schools. Try to answer what they ask. Don't try to change the sentence. Because sometimes you change sentence and it doesn't mean what they ask, and they cannot give you credit. Okay, nah? Number C. Use output 3 or 4 to check if there are different in grading between 4 schools. Still same, right? It's asking if there are some difference in 4 schools. With alpha is equal to 0.05. Now it says specify alpha 0.05. Whenever you see alpha, you have to give me p values. Whenever I give you alpha, you have to give me p values. Yeah? So that you can conclude. Make sure to clearly define any parameter state in hypothesis. Check necessary assumption and clearly state your conclusion. Is this consistent with result B? So this thing is same old thing, those 4 steps. If you remember. Step 1. Step 1. Set up S0 and HA. Right? Because this one are checking if they are the same or some different. think of ANOVA F test. Alright? So this is mu A equal to mu B equal to mu C equal to mu D. HA would be mu I are not or equal. Right? With I is equal to A, B, C, and D. Alright? Step 2. Step 2 is to check for condition. How many conditions do we need? 2. Right? The first we have condition. The first one, for independent random samples. Keep in mind, from this one, you have to check things. Independent, you say for different schools. Right? Random, the question given. Without specify, how do you know that some point will be deducted? Alright, I need to do that because when you do the real research, you need to be aware of that. Step 2, second condition is they all are from normal or and with equal variance. Turns out that the question said that they all are from normals, right? All samples are from normal. This one is given with equal variance. This is from A. In part A, we assume that variance are all the same, so I say that. Okay, in the very first question, we say the variance are all the same. If up here you say variance are not the same, you can say not satisfied. Okay, any question so far? That's step 2, right? Step 3, if you want, you can also get F test statistic, but you can just jump to step 3 by getting the p-values. Alright? You see, this is fine. This is fine. So what you need is a p-value. Right now you have two options. This one or this one. Which one you pick? This one, because the conditions are fine. If second condition are fine, you pick this one. You pick this one. You know? So from p-values is equal to this one, we use ANOVA output. P-value is equal to 0.015, right? 0.015. And then this one is actually smaller than 0.05, which is alpha, so reject S0. Same old step, you see? Get p-value, compare to alpha, reject S0. And if you reject S0, can we conclude that there are difference? Yes. Alright, step 4 would be just answer what they ask. We can conclude that there are difference. I'm going to put dot dot dot. This whole sentence comes down here, right? At significant levels of 0.05. Same old thing. In the conclusion, you have to summarize. You have to specify alpha. Because when you change your alpha, the answer could be different. Without this part, it's always over 1 point. Okay, you see, all 4 steps still fine. That's why when you see the test, need to remember the name. Need to remember how we set up S0 and HA. Need to know what the condition. If you don't remember, make sure it's somewhere in your cheat sheet. I know there are lots of them, but right now you can remember it's good. And then you get the p-value from output compared to alpha. Even though step 1, you can get the result very clearly. All right. We're not done yet. Is this result consistent with B? You see this say there are some different. From B, they're not different, not consistent with B. Something like that. Alright, just fine because when you use different approach, sometimes the answer could be conflict, especially when you have a gray samples. This one is somewhat gray samples. Alright, which one is better? This one is better because this test is customized to check if there are some difference among means. Okay? Part D. Use output 5 and 6 to check if there are different among between average grade in first year. Right? This one is say use 5 and 6. 5 and 6. 5 and 6 is this one. 5 or 6 average. Five and 6, right? What you do, you check the condition informatables include 0 or not. You see A and C, A minus C includes only positive. Some different, right? Or you can talk about P values. Alright? Or you can talk about this too, and you see that C is only in subset 1, and A is only in subset 2. Alright? So something like this from output 5, right? 95% confidence interval for mu A minus mu C is 1.53 to 14.31. This one is greater than 0, right? And then P values for S0 of mu A minus mu C equals 0. HA H mu A minus mu C is not equal to 0 is 0.009, which is less than equal to 0.05 alpha r. Some difference between A and C. Right? Yes?
Do we have to use both of those to get full marks in the test?
This is my answer. You can just pick one. I write down because I have to write all possible answer for you. Alright? But if you use, this is option 1, this is option 2. Alright? Or you can use output 6. Right? C is in subset 1. Subset 1 only. A is in subset 2 only. Imply that mu A is not equal to mu C. You could say answer something like that. Okay. Just pick one that you like. At the end, if you clear what are you going to say, it shouldn't be that difficult. But if you know what's going on in output, you will not know what I'm asking and you will not know what to write. And 1 hour can feel like eternity. Okay? So, part E, suppose we do not assume that they are from normal, but histogram in output 8 are given instead. So this one. Can we assume that they're from normal? Yeah. This one is not so bad. Maybe a little bit this one, but kind of fine. So you talk about bell shape or not. Alright, that's the key thing. If you think they all look bell shaped, it's still fine. If you think that they all, some of them are not bell shaped, then you say they're not fine. Alright, just that. I'm not gonna write it down, okay? Yeah. Yes?
If we choose option 1 and option 2, the conversion will be different, right? And have the conclusion with the at the 95% confidence interval and
Mhm.
the option to put the at the significant level at 0.05.
If you pick output 6, go with that. If you put output 5, confidence interval, just go with confidence interval. If you want to pick p-value, just pick alpha and then you go along with it. Don't make it too complicated. Okay,นะ? Any question? Yes?
So the last question, we assume it's normal
Normal.
because of the shape, so
Yep.
it doesn't have any effect on the answer.
Well, the question, if we don't assume normal, then we look for histogram. The key is to say, can we say that all of them look bell-shaped? If you assume they look bell-shaped, they're fine. That's the keyword. But it's up to you. I think the proper one is this one. Right? But if you think this is not so much different, then you say, well, they all look approximately bell-shaped. So we can assume they're normal. So then everything is fine. Just that. Okay?
What if we don't assume number 2 is bell-shaped? Then how do we answer the question?
If then keep in mind that this one is only asked, can we assume how does that affect to A to D? A to D, if they are not normal, meaning that this one you have to go back to use Welsh. Okay, right? And then for this one also, this I think technically this one I would say to make it easier to say this one's still fine. I don't want to be too technical. But too technical, everything is not fine. But it's only affect the normal. Right? Okay? So I want to simplify things. Right? So your question is that if turn out you cannot assume normal. Right now I'm saying that it's only affect ANOVA. Alright? It's only affect ANOVA. Alright? To make it simple, it will not affect the rest. Because this below here is somewhat some kind of another version of two sample t-test, which can kind of use a version that the variance are not the same, don't have to be normal, this kind of thing. You want to simplify things. If you want to be technical, everything change. Okay, now, all right. So that. Only affect ANOVA. Go to use Welsh. This one. If it's not normal, okay,นะ?
So if it the condition number 2 is have to check out as normal and given equal variance. So is even though it's
This is a simplified version of that. See, the part of normal and equal variance is our second one. If second one are not met, use Welsh.
is okay.
So
They can be very picky, but this one is simplified version of that. Okay.
so you mean that even it's not normal distribution, we can use Welsh test.
Welsh test you can always use because it don't require that to be normal. But if you can use ANOVA will work better. To see p-value is smaller. When the condition for ANOVA is 5, it can be faster to detect difference. Right? Most of the time, the test that require more condition, when the condition are 5, it always has more power to detect HA. That's why we want to use ANOVA first. Any question? Okay, so that's for ANOVA, right? Let's talk about this one. Let me wrap up the topic for the quiz first, and then I'll walk into the software, because if we go over the software and cover the topic, it will be a problem, right? Yeah. So let's talk about this, right? So let's come back to this sheet, right? So this one is one sample, right? one sample for categorical. Before, we have talked about two categories, just yes or no, choose or not choose. Alright? Before, for PCOS, we talk about z-test, we talk about binomial. These two are the same thing. Only that binomial go to normal when n is large. That's why we find the sample size large here. That's what we talk about. That's what we do manually last time, which I will not do manually anymore. Alright? But if we have more than two categories, when you have at least two categories, you could have, think of market share, think of a cola drink, think of Coke, Pepsi, in Thai we have S, something like that. Right? When you have any category, instead of P, you would have P1, P2, P3, or up to PK. Alright? When that happens, your question will be about P1, P2, up to PK. Right? And then you will have some number that you compare. For example, you think of this is Coke, Pepsi, and S. Maybe you compare to 50%, 40%, and 10%. Alright, that's your question. Are they all equal to some number that you want to compare? Or are they not? This one, at least one of the group is not equal to what you want to compare. For example, you work at Coke company. You want to see if your campaign is working or not. You want market share to be changed or the same? Change. Change in what way? Market share on your company is supposed to be higher. Alright? But change can also mean go below. Okay, that's what I said, right? So what we do is that when you're dealing with something like this, at least two categories with we're gonna actually we're gonna use what we call chi-square. Pronounce chi, not China. Chi-square goodness of fit test. Goodness of fit test in Thai we translate to การทดสอบสารรูปสนิทดี Some kind of it in Thai, that's what I have to say. What it means is that, you see, goodness of fit. For example, you have 50, 40, and 10. You want to see if percent is close to 50, 40, and 10. That's what we mean by goodness of fit. That's why it's been สารรูปสนิทดี It has a meaning. The names always have something. It's not just the name, alright? So the condition, right? The condition basically is just it's actually extension of z-test for binomial test. Right now, first one, random food samples. Second one is our expected count is at least 5. It's actually compared to this. But now when you have many categories, the number is dropping to compare to 5. Alright? Let's take a look at the quick examples. Alright? Let me give you a quick example. So let's say we have let's see, 120, and then this one, 75, and then 1, 2, 3. Yeah. So let's say that my question is that, let's say the group 1 is Coke, second one is Pepsi, the third one is S. S is a cola drink in Thai. It's actually spin off of when the company that actually make cola drink for Pepsi and then just now break up, and so they make that one. Alright? So P1 is percent from Coke, P2 is percent from Pepsi, and P3 is percent from S. And you see, I draw samples at 200 people. Turn out that there are 120 choose Coke, 65 choose Pepsi, and then S15 choose S. Alright? My question, right? This one is sometimes what we call OI. OI means is observed count. It's the counting in each category that you observe from the samples. Right? Now, if S0 is true, keep in mind they all equal to some number that you have in mind. Alright? Below here is at least one of them is not equal to what you have. Don't have to be different from what you expect. At least one of them. But when at least one different, it will be at least two different. Okay? But to make it simple, at least one different. Okay, nah? Right? Let me ask, if S0 is true, how many would you expect to see in Coke? How many people should choose Coke? If 50% choose Coke, if you ask 200, how many is supposed to choose Coke? 100. Because that 50% from 200. That is what we call expected count. This is 100, right? How many should you expect for Pepsi? By the way, this is 200 times 0.5, right? How many should you expect from Pepsi? 70, because that is 200 times 0.35. How many should you expect from S? 30. Alright? That's why expect count turn out in this case is N times PIO. PIO is number that you want to compare. Expect count is number that you would expect to see if S0 is true. Alright? Now you have something that you observe from samples. Something that you observe, something that you expect if S0 is true. So if these two columns are similar, which one would you pick? Top one. If O is about the same as E, alright, tend to support S0. If O different from E, reject S0. So at the end, what you calculate is this one. This one, chi is x in Greek. That's why it's x squared, right? It's actually calculated from O minus E squared divided by EI. So what it means is that this one subtract this one, square divided by E. You get one number from Coke, this one, you add those up. You see that this one is square, right? So when they are the same, every pair is 0, small. But if there are some different, right, this thing become large. Alright, so at the end, reject S0 when chi-square is large. Right? It looks something like this. Chi-square looks similar to F distribution. It looks skewed to the left. Alright, and then this part right here is a p-value. Alright? If you don't get it, all you need to know is that when you have at least two category, one samples, and your question is to compare if proportion from each category are the same as you expect or not. Alright, you check condition random samples. Our expected count are at least 5. Our expected count is basically this, you see? 170, 30. Compared to 5, they're all large. This one is just like n times p and n times 1 is p. Because p is p1, n1 is p is p2. Same whole thing, but now compared to 5. And then at the end you get p values. P value is large. You can say this. P value is small. Some category are changing. Okay, yes,
Was the formula, is it 2 or is it Z?
this one,
The chi-square.
the chi-square.
Is it 2?
That's this one,
Sigma.
that's a sigma, that's a summation.
Summation.
Summation. Yeah. All right. The more detailed formula is in the sheet. All right. I think my version here is on this. This both are my version. This one is not simplified. Okay. All right. So before we take a break, right? Let's see. We have this output, right? We have this sheet, right? Now you look at this problem 2 on page 3 of one of the handout. Yeah? An article in Gallup website entitled Social Audit. Gambling. What they do, they want to see, they want to ask if gambling in should gambling be legal? What do you think? Should gambling be legal in Thailand? Yes, so that we can collect tax.
This is already legal.
Right? But if you think you ask like the young people, like baby, like children, would you say yes or no? They would say no because their parents say gambling is bad. They don't know bad or good. Alright? So now let's see. Right now we have what? We have you ask people, they either answer approve, yes, it should be legal. Disapprove, no, it should not be legal. And no opinion. Okay, nah? Alright? And then they also ask age, adults or teen. Okay, nah? Alright? And these are the people that you ask. Alright? Let's focus on A. Right? On A. Regardless of their age. Suppose we want to infer if there are 60% of people who approve legal gambling, 30% of people who disapprove, and 10% of people who has no opinions. Use the result in output B1 to answer the question. Yeah? First, what is the sample size in this case? Yes.
2003.
2024. How many categories do we have? 3. Approve, disapprove, and no opinion. Do we care about the age?
No.
No. Basically, you collapse these two. Basically, just focus on the last row. So this is how many choose approve, this is how many choose disapprove, and this is how many choose opinion. All right. To make it simple, think of this one as a group 1, 2, and 3. All right. The question is that is a P1 equal to 0.6, P2 equal to 0.3, P3 equal to 0.1 or not? That's your main question. All right. Got this, right? You will get this one. I think this one is a somewhat simple question. You will get this one. You have more time. You have 2 weeks before the quiz, right? Okay, huh? So output B1. Output B1 is this one. Huh? Output B1 talk about this output. Only this output. What kind of number that you have to talk about? 60%, 30%, and 10%, right? So what part of this table we have to talk about?
Total percentage.
This one. You compare this one to 60%. Are they similar? Are they similar to 30%?
Yeah.
Some are different, a few different. So it's okay, it's subjective, right? Are these similar to 10%?
No.
It's up to you. And then this is kind of great. All right? If you think they are the same, so let's say they are different. How about that? Right? But keep in mind, this kind of thing is subjective. You just go along. The thing is kind of great. All right? Okay. So, but at the end, you compare P hat to P. All right? From output 1, right? Output 1. P1 hat is equal to 0.603, which is about 0.6, alright? P2 hat is equal to 35, 0.357, which is, you're gonna go along with not the same, right? Stay with that, okay? So this one is, I would say, 0.3. On the same time, right? But the thing is that you talk about this. If they are the same, then you say yes, we can infer. But right now I'm saying that well, seems like this one is larger and this one is smaller, so we cannot infer and take the whole sentence down here. That's minimum dot dot dot. You know what I mean, right? You cannot do that into quiz. Only I can do that. You know what I mean, right? You see same old thing, this is more like using the point estimation. Right? Compare. I want the same, they say the same, not the same. Then it's larger or smaller. Part 2, output B2. Right? To answer the question, make sure to check necessary condition, right? So B2 is basically this one. B2 use output. So let's take a look. B2 now. First thing, right? They will give you, I will give you this kind of output, right? You see approve, disapprove, no opinion. This is O. This is E. All right. Residual is just O minus E, but it's mainly just care of these two. Only worry about these two. All right. And then what you need is basically either one of this. Alright, and this is the test. This is a p-value. Before you use p-value, you need to know what is S0 and what is HA. But right now we have 3 of them. We don't know which one is compared to which one. Alright, see this one? Most of the time, the order will go like this. This one, this one, this one. This one compared to 0.6. This one compared to 0.3, and this one compared to 0.1. Alright, so in this case, S0 would be P1 equal to 0.6, P2 is equal to 0.3, and P3 is equal to 0.1. Right? Now, okay with that? Right? Now, you see there are p-value 2 of them. Which one do we pick, right? You see this one is called asymptotic. Asym stands for asymptotic. Have you heard of this name before? Have you heard of the asymptote line? Parabola, right? A long time ago, that's what we heard. You see, if you remember, have this line, right? As a line, asymptote line is what? Asymptote line is when your parabola converges to that line, but it's never touched. Instead, asymptotic implies last sample. Asymptotic implies last sample. I don't know why they say last sample. But asymptotic means last sample. It's actually talking about this one. It's talking about this part right here. It's actually talking about this condition. Meaning that p-value is approximate, only work when the condition of 2 are fine. Alright? Alright? So if the condition 2 are fine, asymptotic p-value is okay to use. Okay? Right now, asymptotic is only 5 when expect count are at least 5. Alright? Go back in here, you see. Like in this case, large, okay to use. But you see that is another one, exact p-value. Exact p-value don't need n to be large, it can always be used. To me, if you have this option, exact p-value, just use exact p-value and you're done. That's why in my condition I say no need that when for exact case. Alright? You know that for Jula actually pays something million to actually have this option. But still some ajahn don't use it. And they learn that one. This is a classic one. This is a new one, a better one. If you have these two, just pick this one. And you don't have to check for n is large. Alright? Okay? This one always works. This one only works when all three are at least 10. Sometimes, most of the time when n is large, the result will be the same. If the sample size is not large, the result will be different. And this one always better. Okay? Alright? So, in this one, large or small? Large. Can we say that it's 60%, 30%, or 10%? No. Because this is small. Small, reject A0 and pick this one. Okay, just that. Okay. So in this case, I say choose exact p-values equal to 0.00. Check condition, right? Condition, the first one. Do we have random samples?
In the question it says it's given alpha as 0.01.
Right. So that is one. Assume, right? Random samples. And two is at least 2 or 2.4, which is at least. Something like that. Same old step can also apply. You see, you start by step 1. This is your hypothesis. Step 2 is to check for condition in this one. It doesn't say random, so I say assume. Alright, expected count, I look at the table. The table we have 3 values, the minimum one is this one. So I say all of them is at least 202, which is at least 10. At least 5, sorry. At least 5. So conditional 5, right? And then this one, if the conditional 5, you can also choose asymptotic one. But I choose, if I have exact, I just use exact. Sometimes I give you, sometimes I don't. Alright? And then this is reject. So we cannot infer, I say cannot, see? And then just take the whole sentence and then also specify your alpha. Right? That's a chi-square goodness of fit test. Make sure remember the name because sometimes I just ask for the name. Chi-square goodness of fit test. Sometimes they say GOF. You see, like if you do some data analytics, sometimes it's the GOF case. Goodness of the case. Let's take a short break.